Good afternoon and welcome everybody. Welcome to this week's Tech Ed webinar series. Today we've got a continuation of a presentation that philip.negus from APL we did part one a few weeks ago on thermal performance. So Philip today will be continuing a discussion around thermal considerations for window systems, forming part of the window envelope and looking at thermal efficiency. Presentation will cover factors governing condensation and the importance of thermally improved window systems, and it may well cover some low E glazing considerations. If you didn't attend our last session, Philip has spent almost 30 years in the aluminium window and door industry. Philip began his career in aluminium windows on the factory floor, fabricating the product and moving through to estimating and project management, covering all aspects of manufacturing and the process. For the last 5 years, Philip's been working for APL in the market development department, engaging with architects and designers across New Zealand. Philip's manufacturing background affords him the technical knowledge to offer solutions to somewhat challenging details, depending on the project, and along with the other members of the market development team, he continues to promote new product development to assist architects and designers.
Thank you, Matt.
Philip, good afternoon. We're just getting your screen sorted.
Yeah, I had it sorted before and now it seems to have not wanting to play ball, so can you see that okay?
Yeah, I can. That looks perfect.
Well
so
done.
Over to you, Philip. Looking forward to part two. Thank you.
Thank you, Matt. So I'd just like to clarify, we've marketed this as part two. In actual fact, there is a little bit of recycled content in this presentation regarding thermal performance, but being that it is a part two, I've added some new content regarding a specific building typology which lends itself to thermal performance, and you'll identify that immediately as we get into it. So I'll just touch briefly on that typology at the beginning, and then we'll head into some more specific information around the window systems, glazing offerings, and some of the considerations. So I guess what I want to talk about is apartments, multi-level and multi-unit. So, I mean, what's the difference? Apartment refers to a multi-level building that's mainly residential in use. But the primary characteristic that differentiates between them is that a multi-level building tends to have horizontal separation, whereas multi-unit can be any one of a series of terraced style homes. Why would you choose multi-level? Well, there are a few reasons what I've jotted down. I'm sure there are many more. I think the one, the point at the end for us from a window systems company is probably pretty relevant with regards to thermal and acoustic performance. Typically multi-level, if you look at the sort of material choices which are used, often it's precast concrete, sometimes it's double frame timber walls, but often precast concrete satisfies not just the acoustic requirements between intertenancies, but also some of the fire regulations as well. So, hey, look, indoor air quality is a key consideration for apartments, and obviously we do have solutions around that as well. But it's also, we're starting to see some critical thinking around thermal comfort and the natural ventilation solutions in an apartment building. So apartments are a popular building typology around the world, have been for decades. It wasn't always like this. Often they were seen as a cheap solution to housing problems using poor material selection, floor designs, very little consideration for the occupants' comfort or well-being. To give you an example of some of those, I did a bit of a Google search, didn't have to look too far really to come across some pretty awful apartment building designs that look like bunkers. This one here that you're looking at is actually an apartment building in Naples. This next one is in Belgrade. There's another one here in Lithuania. And of course the the well-renowned and controversial Gordon Wilson flats in Wellington, which of course there's a bit of a cloud over these because the university purchased this land and wanted to demolish it, and now it's considered a historical landmark. But it will come down eventually, but and they will replace it with something for the campus. However, there are always options to this. These are examples of some pretty average sort of apartment buildings which were typically built back in the 60s and 70s. There are some very ingenious and very modern, sleek and luxurious looking apartments nowadays. This is a few examples of what we've seen in the marketplace. And again, you know, they're not necessarily specific to New Zealand. You see these all around the world, and New Zealand is fast catching up with the rest of the world. This is actually, I quite like this one, only because it's a converted water tower in the UK. So someone's actually spent quite a bit of money in converting that into an apartment. This is in Canberra. I was there some years ago and took a picture of this particular development, which was done by Molongo Holding Group. They've done quite a lot of work in Canberra and designed these new apartments. This is actually an apartment building in Auckland. It's St Mark's Apartments in Newmarket, only recently completed. Made the Property Council Awards. I think it was winner best in category, Patterson's with the architects. And this is another new apartment development on the North Shore in Browns Bay. So, hey, they've changed in the way they look, the way they perform. There's a lot of windows and doors, obviously glass balustrades. So obviously, you know, much more consideration for the occupants and how they live. The other thing that's affected the apartment market is some of the code compliance around the products. Previously, or you know, sort of up till now, we've been looking at 4211 and 4284. These are typically, you know, specifically engineered designs, so they're above 10 metres in height, not of timber construction, so they're not generally covered in 3604. But they do come into 1170. The other code that was just recently added, or compliance, was EM7, which is actually a cladding test, E2VM2. But it actually does relate specifically to apartments or buildings that are under 25 metres in height. So the reason why I thought this was relevant was because it does actually have quite a profound effect on window systems or material selection as far as the exterior facade. And the reason why they're looking at this is typically that 4211 doesn't test to the high pressures which are often demonstrated in an apartment building or a multi-level building. And 4284 was primarily designed for facades, so not really opening and closing products. So Brands proposed like an alternative scope to 4211, which included pressures beyond 2.5 kPa. So if you take a closer look at it, you know, what does it mean for window systems and cladding? As I said before, 4284 was designed for facades, for non-opening or closing products, and 4211 didn't necessarily test to the higher pressures. So EM7 the proposal is to have those higher wind pressures. We've got a number there of 2.25 kPa SLS, which actually, I think is about 3.7 in a ULS figure. So they would test to those higher pressures, then they would do an air infiltration test, followed by a seismic test of the system, so just a small shake, then a second air infiltration test, followed by static water and a 3-stage cyclic test. So the testing is a lot more stringent, and this is obviously to demonstrate that the products are being used fit for purpose. I know of a few examples where apartment buildings have been built, main contractor has been awarded the contract based on the price they've provided, and then they've gone and put residential joinery into an apartment building, which is not fit for purpose. And in some cases, you've got a new apartment building where the windows and or doors are actually leaking, simply because they're not designed for those sorts of wind pressures. So, what does this mean for material suppliers? It means that you could quite possibly develop a range or have a range of products which comply specifically to the apartment market, which then in turn makes it a lot easier for specifiers, architects and designers to choose that product, to select it, knowing that it's going to do what it says it's going to do. Of course, having a range of EM7 compliant products means you have to go through that testing regime as well. So we have looked at that, and hey, we are already developing the next generation of cold and warm products for our market. We will probably see something in the next 12 months. There'll be a range of large platform systems, both as a solid frame and thermally broken products. So we'll just get back into thermal performance. Thermally broken windows are used to reduce significant conductive transfer of heat through the aluminium. So what it's doing, obviously, it's isolating the outside surface of the window system from the inside. And that has beneficial effects to the window system itself and the internal environment. I found this report, which came out of the UK. It's a little bit dated now, 2013, but it's still very relevant. And they talk about the causations of condensation and some advice of how to deal with it. It's important to remember that condensation is actually not a window problem. As moisture in the air, as the air cools, it can no longer hold the moisture in the air, and as it cools, it actually will condensate, and it will condensate on a cold surface, and typically that'll be a window system. Maybe not so much the glass, but you certainly get it on your window frames. So I won't go into too much detail about the factors governing condensation, because I think we all understand that. It's the vapor content in the air, so that relative humidity. So the inside room temperature versus the outside, and then of course that temperature differential. So when we talk about it not being a window problem, I want to see people, it's the way they live their lives in their homes, which usually determines how humid the air is inside a property. And whenever I speak to architects or designers or get up and do a presentation, we talk about thermal performance. We always try and encourage people to, in the first instance, open your windows just to ventilate your house or whatever space you're actually occupying. Again, if we're looking at condensation, some of those factors, this here was just an excerpt out of the report, which I thought was relevant to a lot of the homes that we occupy now. So obviously ventilation is a problem, and condensation is usually a result of poor ventilation inside a property. And with today's buildings, which are designed to be draft proof, they're very tightly sealed up. We can no longer rely on the fabric of the building to actually provide ventilation through the building fabric. Of course, we don't want that either, because that's how you can actually get moisture inside the materials. But it does mean that the building is wrapped up really tight, becomes airtight as well, and traps all the moisture in there. So condensation, we've heard some horror stories about that. In fact, one of our fabricators used to do a lot of work for Housing New Zealand. I think I remember in one situation where they built sort of social housing development. They specified the windows as double glazed with double tongue sash handles, restrictor stays, and sash vent. So giving the occupants every opportunity to get some ventilation through the property without having to have the windows necessarily open. So being able to provide some ventilation in a secure way. They'd go back and do some post-occupancy testing and find mold and mildew growing behind the curtains. So they sent an instruction through to the manufacturer to say, hey, look, move the slide out of the vent so that it was permanently ventilating. They would then go back and do an inspection of the property another 6 or 9 months later, only to find that the holes have actually been taped up by the occupants. So, you know, gosh, it's a real problem, ventilation inside some of these homes. This is sort of a graphic that brands provided. I think it tells a pretty good story with regards to where or how to keep a healthier home with regards to air changes, healthy temperatures. And we've all seen these, there's lots of these graphics around, but we need to try and keep telling this story because I think in some areas the message is simply not getting through. So obviously we have a range of products which can assist with this. We've got a couple of aluminium thermally broken products. And as I say, we're developing a new range of products on larger platforms, which will probably see these, will be the next generation of window systems really, and change the way we install windows and doors into our homes. So it's pretty exciting. We're really looking forward to it. You'll notice that in the performance figures down on the right-hand side there in those bullet points, obviously just stating, you know, the IGU thickness, the U and the R values. Now they're using pretty high quality low E glass. So it's not just clear glass with air-filled units. These are argon-filled high-performance low E units to get those R and U values. You can increase the performance just by changing the position of the window in the wall, of course. And there are a couple of projects underway. One of them is with the Window and Glass Association in conjunction with brands and MB, and that is to develop a range of in-wall installation details, which are effectively recessed windows. We've been talking about them in the industry for years and years, and I think everyone understands that the position of the window in the wall actually can make a profound effect on how the windows perform. And you'll get no argument from us, we understand that. But I think in New Zealand particularly, we've been far more focused on the weather tightness of our buildings as opposed to the thermal performance. But we're now starting to see quite a shift in the marketplace towards thermal performance. And about 4 years ago, we introduced a UPVC system to New Zealand. It's by no way is it the first one here. UPVC has been in New Zealand for well over 35 years. In another life, I was manufacturing UPVC windows here in Auckland about 30 years ago. They were like the first generation UPVC systems, so they're only like a 3-chamber system. I think now they're up to about 7 chambers. And what I mean by that, you can see the cross section on this climber product. It's the number of chambers, the air pockets, if you like, from the outside to the inside, which ultimately determines how well those sections are performing thermally. And hey, look, there are limitations around a UPVC system, and I'll cover that a little bit later on in this presentation. We've brought a 5-chamber system here to New Zealand. It's it's an entry-level product really for New Zealand. There's a lot of UPVC product being brought directly into New Zealand, which can do bigger spans, have more chambers and so forth, but it's a minuscule part of the market. So we just brought this here just to test the water, and for those people who were what I would say thermal enthusiasts, climber probably fits that niche market. We also have thermally broken facade systems. We don't have anything smaller than the 168 thermally broken structurally glazed system. Someone asked me the other day if we had a smaller system, but we don't. Whether we'll get there is another thing. I think we will probably offer thermally broken products in our smaller ranges, because obviously we've got glazed facade systems that'll go from 100 mils right up to about 175 mils in depth and size. And of course, they're all performance-based systems. But the 168 kind of covers all eventualities at this point in time, so we're quite happy with being able to offer that. We also have some thermally broken roof lights, and for those of you who are putting overhead glazing into a house, you should definitely consider these. That's where all the heat is going to travel to, and obviously will escape through any non-thermally broken window a lot faster, and it will generate condensation much quicker than a vertical window system as well. Put this chart together just really to assist people with regards to the product's performance, where we position them in the marketplace, and some very, very rough square meter rates. You know, as I say, they're very rough, so you can't really sort of hold us to account on these. But if we're using, say, a solid framed residential system down on the bottom left, with approximate square metre rate of $500 a square metre. The thermally broken version of the residential system is about $575, so it's about plus 15%. It's the same with our Metro series as well, which is our mid-range product. The same cost differential when you go to a thermally broken version of that. So it's about plus 15%. And the Climber at the moment is priced at around about the same as the Metro Thermal, although it does have a slightly lower performance threshold. And what I mean by that is you can't build it to like 2.4 high with all manner of different configurations and so forth. Climber is very much a standalone product. And there's a very good reason for that is, you know, in our current aluminium die library, we have about 7,000 shapes, which allows us to do a great many different things. With Climber, when we bought the UPVC product here, we only actually brought 22 extrusions. So very limited in the number of, well, the types of configurations that you can build with it. And that image there is about what you can build. But of course we didn't bring it here for that. We brought it here for its thermal characteristics. And this chart really highlights the thermal performance characteristics of all of our systems. You can see that the architectural series at the very top there performs the poorest with regards to, you know, your U and your R values. And that's simply because of all the massive metal within the system itself. So there's a lot of thermal bridging going on there. As you get lower down, of course, you look at those thermally broken products, the residential and Metro thermally broken got the same performance figures. So you can get them up to like 0.53 with your R values. There are some other glasses now which will actually increase their performance and get them up to almost an R 0.6. And of course, Climber is sitting above those thermally at 0.66. Climber, we can actually triple glaze that. It's the only system we have currently to allow for triple glazing. But the new products that we are designing now for the next generation of windows and doors will be, as I said before, they're a large scale platform. So they'll be like they'll start at a 45mm cold system and maybe go up to like a 55 in a warm system, which will allow for triple glazing as well. This chart is showing you a comparison between our commercial systems. So a solid 150 structural glaze system at the top, the architectural series, which of course is the same numbers we had on the previous chart, and then the thermally broken structurally glazed system. So I mean, the performance increase isn't huge, but you know, they're all still quite small numbers, but if you show them to the mechanical engineer, they do actually make quite a big difference to the internal environment of a commercial building. This is the range of standard current installation details. This is actually showing the Climber product in an over cladding, over cavity situation. So these are our E2 compliant details at the moment. And of course, I mentioned earlier that the Window and Glass Association are working on a set of in-wall installation details. This one shows a residential thermally broken system. This was actually part of our own submission, which we put to Brands and MB about 18 months ago. And then since then, of course, the Window and Glass Association have picked that up and ran with that ball. So they've actually drawn a couple of details, one of them in a 90 frame wall and the other one in a 140 frame wall. So by bringing the window in line with the insulation, of course, you're going to get much better thermal performance. The problem has always been having a compliant detail. And so in this particular case, you're relying on a set of head jam and sill flashings to actually keep it weatherproof. But it's actually getting the water out is the problem. It does actually make the installation more expensive as well, and adds complexity to the installation as well. So it's not for everyone, but for people who want thermal performance, they would probably prefer to use that as opposed to mounting it over a vented cavity. I just want to show you this case study, which is actually a commercial building. Of those of you who have been to Christchurch recently or in the recent past, Turanga is the Christchurch Library. So we actually used our 168 thermally broken structurally glazed system. They used various different glazing systems. In actual fact, on the exterior facade, they used a couple of different triple layered low E glazing systems. I don't know if you can pick it up on this particular image, but the lower level glazing, sorry, the first level glazing, you can see the vertical white columns. They're actually still quite white, whereas the spandrel panels in the 3 floors above are quite green, and that's due to the triple layered silver coating that they have on the low E on those upper 3 levels. Obviously, it gives a bit of a tint. There was a real focus on energy efficiency in this building due to the large expanses of glass. And on the end of this building, you can see with the extensive use of those box aluminium fins, really from a shading perspective. But it's supposed to be, or I believe it's supposed to be, the most modern commercial building in the Southern Hemisphere, which obviously includes the cutting edge technology in the glass, the box fins as previously mentioned. They also built a very large overhead glazing system into the top of the structure, which floods the stairwell with lovely natural light. They've used a single silver low E glass on it with a frit pattern on the glass, about 30% frit, and that was just really to reduce some of the solar heat gain. Just touch briefly on the glass before I finish up this presentation. This is actually some performance data that I got out of one of my colleagues. Really what we're demonstrating here, what we're trying to show is the difference in low E glazing. So in the green box at the very top is actually just a clear on clear makeup. The visible light transmission, which is the VLT. Then you've got the shading coefficient in the blue column, and then the U value in the red column. So those are the numbers we're currently looking at. So the top box is, as I say, just a fairly standard clear on clear. Then the dark green is entry-level residential low E glazing. So your VLT is reduced to about 67%, and your U values at about 1.5. Then if you look at the more commercial grade low E glasses in the red and the blue box down the bottom, for example, we've got a really good U value at 1.1. So the glass is performing very well at that point. It's got a shading coefficient of 0.29, which is very high, which means your visible light transmission is quite severely impacted. So only 48%, it makes it very dark on the inside. It performs really well with regards to solar heat gain, so it reduces the heat entering the building and performs very well with regards to heat loss as well. But I think, when you're selecting low E glasses, you've got to be mindful of your visible light transmission, because you don't want the building to be too dark, people having to switch lights on a cloudy day. So that was really what that black box is highlighting, is the various different VLT performance figures in those glasses. This table here, because we do often get asked the question about triple glazing versus double glazing. Yes, you'll get improved thermal performance with your triple glazing. There will be an impact on the visible light transmission, and of course, what was I going to add to that? You do actually get an increase in external reflectance with triple glazing as well. So glass is typically being used just to control noise, glare, solar heat gain, heat loss, and fading control. For those of you who aren't aware, we actually built a glass processing plant in Cambridge last year. That factory is now operational. It's been making glass units now for about a month for a handful of our manufacturers. We did actually go out to some glass suppliers and got a specific glass made for New Zealand. So rather than offer a range of different low E's, we actually settled on one that specifically works very well in New Zealand, which is called Solux E. And this is a very basic chart showing you that the industry standard glass on the left compared to the AGP system Solux E on the right. It actually has much better performance with regards to solar heat gain and fading reduction, but also thermal comfort. So obviously it's keeping a lot more of that heat in as well. So AGP is the name of the company, Architectural Glass Profiles, which is part of the APL group. And we will ramp up production in that glass plant, and the remainder of our North Island fabricators will come on stream as capacity increases. Currently, we're only providing about 5 manufacturers in the Waikato Bay of Plenty region. But as I said, as capacity increases, we'll probably cover the rest of the North Island. For any more information on our products, you can go to EBOS, Master Spec or Product Spec. We do actually offer Master Spec section support writing. Both myself and my colleague Tony in the South Island can offer support in that area. And if you don't already have one, we have a new specified guide. It's been out for about a year now, but still, obviously with our lockdown, there was a lot of people who didn't have access to this. So we do offer, obviously, assistance to architects and designers with regards to, project-specific work. If you're unsure about a product to use, you can contact us. So very briefly, a summary. Thermal efficiency is a small number of improvements, both with the frame, maybe the position of the frame in the wall, and of course the glass, and then either the air or the low E on the inside of that airspace. But houses have been completely sealed up by the installation of cavity wall insulation, loft insulation, double or triple glazing, and of course they've become a bit of a moisture trap. The most important thing I want you to take away is probably that condensation is not a window problem, but the appearance of condensation is usually as a result of poor ventilation. So there are some low E glasses available. Just be aware of the ones that you are specifying. Thank you, and that's me.
Hey, thanks, Philip. A couple of questions to quickly run through here. One, earlier on you were looking at the in-wall details. So question, do the extra timber below the window frame not negate the thermal bridging because of the poorer performance of timbered insulation? And can the timber be reduced or avoided for window installation in the same plane as the insulation?
I suppose, was that in reference to the size of the timber packer? Is that what we're referring to there, Matt?
That's what I read into, there from Frederick.
Yep. So there's a couple of things there. First of all, you need to have the window positioned in such a way that you can actually get a flashing in and around it, and then of course have access to it if there are any issues. I think the second one is that it has to be thick enough so you can still provide adequate fixing on the inside of the window. And I think as, if you make the packing so narrow that you can't get either a timber jam liner or some sort of adapter onto the back of the frame, then you're really limited as to how you can then fix the product into it.
Okay, is that... If we haven't answered that yet, we might come back. Also, Tess has got a question here. Tess, thanks for your honesty. She goes on to say, are the thermal recess details available yet online? And if so, are they in CAD format?
Not available as yet, Tess, unfortunately. Sadly, when you get to legislative level with regards to changing the code or providing an alternative detail for E2 AS1, things move at a glacial pace. So, hey, I was aware of these in-wall installation details about 3 years ago. It took about probably 2 years for the Window and Glass Association to become tasked with getting those details submitted to brands as a recommendation, which then brands make to MB. So, yeah, in answer to your question, no, they're not available yet, but maybe, hey, I don't know, how long's a piece of string? It might be 6 months, it might be 12 months.
Enough about windows, and thank you for covering that in such detail. But we must move on and talk about gutter and downpipe design. So, indeed. Philip, thank you.
No worries.
We'll see you a little bit later on.
Okay.